Okay, so here is your video answer key over our very first quiz for hopefully prepare you for the test. So here we go. Number one, which of the following masses is the largest? So if we remember, and we'll use this a couple times, King Henry died unusually or by drinking chocolate milk. Right? These are all from low to high. We are increasing in unit. So our highest, we're just looking at the prefixes, our highest, and this is gram, meter, liter, are all your bases. Your highest one, your biggest is going to be kilo. Which of the following is not correct? Well, this one is correct, which many of us didn't circle, but then got wrong on the back, and we'll talk about that here in a second. So we're looking at B and C. So which one of these is incorrect? Well, if we look at our King Henry deal down here, we know that grams, G and G is our base unit, and that centigrams or centi is down here. Okay, so is there 100 of these in one of those, or 100 of those in one of these? So it makes sense that if this is our base, it's going to make up, these are much smaller units than this, so we would need to have more of these to equal one of these. So C is true, B is not correct, so B is your answer. Number three, what conversion factor would you use to convert kilometers to meters? And we're not looking for an answer here, we're just looking for the math. So if I'm taking kilometers and I want to turn it into meters, that means meters needs to be on top because I need to get rid of that kilometer unit. That means kilometers would need to be on the bottom. That way I can cancel it out and I'm left with meters. All right, so that should take care of B is not correct because we have meters on the bottom, and C is not correct because we have meters on the bottom. Well, then I need to use my King Henry deal to figure out how many kilometers are in a meter, or vice versa. And I know that kilometers is the largest, so I'm going to put the 1 there. Kilometers to my base meters is 1, 2, 3. So that means there is 3 zeros, 1,000 meters in 1 kilometer. 1,000 meters, 1 kilometer. A is my answer. Okay, the next section, 3 different people with their measurements. Which person was using the most precise instrument? Well, when we look at precision, we always look at the decimal spots, because the more decimal spots we have, the more precise the instrument is. So who has the most decimal spots in their answer? Brian. Okay, and which is the estimated digit in Brian's estimate measurement? It's always your last digit, whether it's a decimal spot or not, it's always your last digit. So in this case, his last digit is a 2. I should have added 2 there. If you put something like 0012 or 0.12, or there's 4 estimated digits, those are all incorrect. You need to have 1 digit because I'm asking for 1 digit. There's only 1 estimated digit. How many sig figs are in this answer? Well, we have 2 non-zeros, and then we have a sandwich 0, so that makes 3, and then we have a final or trailing 0 after your decimal, so that makes 4. These zeros up front are not sandwich, and so they are placeholding zeros. Okay. Further down, which is the most correct measurement of 375 grams in scientific notation using proper sig figs? So I know that I have how many sig figs in my given. 1, 2, 3, and I have actually 4 sig figs in my given, right? And so if I want to turn this into scientific notation, I need to get that decimal between these 2 numbers. So I move it 1, 2. So now my number is 3.75, and that 0 still counts because it's a significant number, which means I moved it 2 times, 10 to the second. So that means this would not be my answer because there's no 0. This one only has 3 sig figs when my given has 4. So my best answer is D. This one moved the decimal in the wrong space. This one does not have that decimal in the right spot as well. So perform the calculations below, report in sig figs. So here you could use your calculator. So 2.25 times 90. My calculated answer is 202.5, but that's not using correct sig figs. So because I multiplied these, I'm looking at all of them to look at my weakest link rule. And so this one has 3, this one only has 1. That 0 is a placeholder, so I can only report to one sig fig over here, and there it is. So 2 is not my answer because I forgot these placeholding zeros. 200 is my answer. If you put 200.0, you've now created another sig fig and sandwiched all of these, so there's 4, not 1. So that is incorrect. 200 is your correct answer. Letter B, 55.693 minus 20.7. Put that into your calculator. You get a calculated answer of 34.993. And I need to use sig fig rules. So because we're adding and subtracting, I'm only looking at digits after the decimal. So in this one I have 3, and this one I have 1. So that means I can only have one digit in my decimal spot. And so I use that 9. That 34 is what I'm going to start with. Well, then I look at, and that rounds that number up to 10, which is going to round that to a 35. Well, 35, I still don't have one digit, so I need to add that 0 to have one digit in my decimal spot. And so 35.0 is correct. 35 is incorrect. All right, down here with density. So you have, this is the formula, calculate the density. So I know density equals mass divided by volume. Well, my mass is 28.5, and my volume is after water displacement, which is 49.1 minus 45.5. So my total volume is 3.6. All right, centimeters cubed, and this is grams. So when I divide these two, 28.5 divided by 3.6, I get a 7.9166, and a repeating 6. And so I need to remember my sig fig rules because I'm dividing here. I look at all of my givens to figure out how many sig figs I need. Well, 3, 3, 3, 1, 2. There's my third sig fig, so I use that 6 to round that 1 to a 2, 7.92. And then it should be grams per milliliter or centimeters cubed. All right, you make sure you have your units and the correct sig figs and work to get all your points. This was worth 3 points. Okay, on the back. Accuracy and precision. So accuracy refers to, so a lot of people choose between B and C because they're very close. This is calculated value and this is the accepted value. Well, accuracy means there's a known answer, and that is how close you can get to that known answer. Well, that known answer is also called your accepted answer. Your calculated is also known as your measured. This is going to be talking about precision. Accepted will talk about accuracy, so B is your best answer. Okay. Number 10, we're converting 200 milligrams into grams and kilograms. All right. So how I did this, you start with 200 milligrams 2 times because I need 2 answers. And I know that for my King Henry, from milligrams to grams is 1, 2, 3. 3 times. Milligrams need to go on bottom, so it cancels out, and I'm going to be left in grams for my first one. And I know that grams is the bigger unit, and so there's 1,000 milligrams in 1 gram. When I do this math, I can move the decimal. It's currently here. I move it 3 times to the left because I'm dividing. 1, 2, 3. It should be 0.2 grams as my first answer. And then I can do the exact same thing as I did up here, but instead of going to grams, I'm going into kilograms. And I know that kilo is my bigger unit. So I'm going from all the way down here, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. And I don't need a calculator for this because I can just move the decimal. 1, 2, 3, 4, 5, 6. and I can replace these zeros. So this should be 0.002 milligrams. Now, just a side note on some of these. Most people got 0.2 grams, but I had a lot of people put, because they saw these two here, 0.00200. So by writing it this way, what you've done is you've added 2 extra significant figures, and that technically is wrong because our given only has 1. In this case, these 2 zeros are not significant. That 2 is, so this still has 1, and this one has 1. I did not count off for this time, but just be careful. 11, number of milliliters to centimeters cubed. Now, a lot of you didn't pick this as a wrong one because this is correct. 1 milliliter equals 1 centimeter cubed. On the back, 1 centimeter cubed equals 1 milliliter. This is straightforward. This is a milliliter. So if I have 200 of these, I should have 200 milliliters. No conversion really needed. It's a 1-to-1 ratio. Number 12. Each large pizza can feed 3 teenage boys. How many pizzas would be needed to feed the Oak Ridge football team? So our given is 56 boys. And so I want to get out of boys and into pizzas. And each large pizza can feed 3 boys. So I know that 3 boys for 1 pizza. This equals, out of boys and I'm into pizzas, 56 divided by 3 gives me a calculated answer of 18.66. However, this is pizza, and we can't get 2/3 of a pizza, so we're going to have to buy that extra pizza. So this should be 19 pizzas. Okay? Labels count here. 13. You spend 242 minutes in chemistry class each week. How many minutes will you spend in chemistry at the end of the school year if the given is 36 weeks? Well, in every 1 week, I spend 242 minutes. How many minutes? So I want to end in minutes, so I'm done converting. So if I take 36 times 242, I get 8,712 minutes. All right. Now, because this is just counting minutes, we don't really need to turn this into sig figs. Same with the pizzas up here. We're just counting pizzas. There's not necessarily a true measurement. Okay. However, if you turn this into sig figs, because you're thinking, well, 2 sig figs, if you said 8,700 minutes, I took that as well, and that's okay. So either one of those answers was acceptable. 14. You have 1 mole of aluminum atom has a mass of that. How many grams are in 2.7 moles? So if our given is 2.7 moles of aluminum, and I want to turn that into grams of aluminum, well, I know for every 1 mole I have that amount. So 1 mole of aluminum is equal to 26.982 grams. Moles of aluminum cancel out, and I'm left in grams. So if I take 2.7 times 26.982, I get an answer of 72.8514 grams. But because these are measurements, I need to look at sig figs. Well, here's a measurement, and here's a measurement. So 2, 1, 2. There's 1. There's my second sig fig. I use that 8 to round it up to 73 grams of aluminum to be the most correct. And then the last one. You needed your formula of theoretical minus your measured, all of your theoretical, that's the absolute value, times 100 is your formula. So in an experiment, the atomic mass of copper was determined to be this compared to the accepted value of that. So your accepted value is also your theoretical, so it should be 63.55 minus your measured, which is 62.37, all divided by your theoretical, 63.55. Now, if it happened to be negative, that's where the absolute value comes in. This one will not. Minus 62.55. 0.37 divided by 63.55, and you get this number, and then I'm going to times it by 100 right away. So my times 100, that comes out to be 1.8568. Well, sig figs, there's 4 sig figs here, and there are 4 sig figs here. These are measurements, so 1, 2, 3, there's my 4th. I use that 8 to round that 6 up to a 7, so my answer should be 1.857%. You did get a point for putting your percentage there, and you missed one if you did not. Sig figs counted for this one, and there you go. I hope that was helpful.